Hi, welcome back to the XII Sound channel and part 21 in the series all about my Project 12 DIY modular analog synth. In this video we'll look at my latest VCA voltage controlled amplifier module. Now I've done something a little different with this module. It's a VCA with a dedicated attack release envelope generator built into the same module. So it's kind of like two circuits in the one module. In actual fact, I built them as two separate circuits and then linked them together, but more of that later. The VCA part of it is a circuit designed by XII. I'll put a link to his video on it. Do go and watch that video. He talks through the design process for the circuit, explains what the components do, why he's chosen the ones he's chosen, but also he kind of brings up the issue of using matched components. So the transistors, it's a classic transistor VCA design, but for it to work the transistors need to be fairly closely or ideally properly matched transistors. He also talks about, for better precision, matching some of the resistor values as well. This might sound a little daunting and might think, well, you know, that rules me out building this thing. But if you've got one of these, a multimeter, if you haven't, then you should have, dealing with DIY circuits. They're not that expensive, but if you've got one of these, and it does have, like this one, it's got a little socket you can plug transistors into there, so you can actually test the transistors and get readout of values on there. And really all you do, you just stick transistors in until you get two that have the same value readouts. Of course you can match your resistors and whatever with this as well. Alternatively, I picked up this little device. Now this is a component tester, but it's a kind of slightly more intelligent component tester. It's got a little dip socket there, and you can plug components in, press the button here, it will test the component and give you a readout of its values, statistics, what have you on this, what it is, and what the various values on it. It will test resistor, resistance, capacitance, it'll test diodes, and it will test transistors. And you literally just plug them into the socket, clamp them down, press the button, and it will give you a readout of what the component is and what all its values are. And it's a really quick and easy way of not just testing components, but matching values of components, because you basically get an instant readout, almost instant readout. I found it really useful because sometimes, particularly if you've got those little ceramic disc capacitors trying to work out what the values are, stick it in here, it'll tell you. If I remember rightly, I think it was less than £10. And if I can find out where I got it from, I'll put a link down below and you can go and have a look. But I'm sure there's several variations on this theme out there. There's lots of these little kind of gadget kits around, so if I find the link, I'll share it. But yeah, go and do a search. Look for something like that. All right, rambling a little bit on there, but that kind of I find that very useful. So yes, so it's not that difficult to match components. You don't have to go and buy expensive match components. So, you know, buy a bag of cheap transistors and find two that are either matched or very, very close. Same with the resistors and everything else. So don't let that issue put you off building the VCA. So if we look at the circuit for the VCA, I've redrawn it with a slight modification in that I've put a CV level control on the CV input to the circuit. So my version of it looks like this. and then I've taken that circuit and put it onto strip board as usual. So the strip board layout I've used looks like this. Now if you didn't want to have a dedicated envelope, you could literally just build that circuit and you've got a VCA, a voltage controlled amplifier, and work perfectly well with it, an external trigger, no problem. However, I wanted to try and put a little bit like if you buy one of the pre-wired synths, from likes of Korg or whoever, they tend to have dedicated envelopes for the VCAs and filters and things like that. So I thought I'll build a module that's actually got the dedicated envelope in there. Now, the envelope design I've used it's the same envelope that I built way back when I put my Project 12. This is Project 12. My Project 9, my first synth, was a 9-volt one. My Project 9 synth, and it's an op-amp attack release envelope generator designed by Nathan Ramsden. Really good, really robust. I've used it a few times in a few things, and it never let me down. It's great. And attack release it's generally good enough for most applications, without going into the kind of ADSR, full envelope range. But that's not for this video. That's another time we might look at something like that. What, I don't know, whatever. Anyway, rambling on. But what I've done is I've included a loop function on this envelope design. Now, the loop part of it is once again courtesy of Moritz Klein. Again, I'll put a link for that. I'll also put a link for my Project 9 version of the envelope, so you can go and look that up. But yeah, look up the Moritz Klein video and see the reasoning behind the loop function. He claims that it'll work with most envelope generators. So yeah, interesting. It does work with this one. So redrawing the Nathan Ramsden envelope with the loop function on it, the circuit diagram looks like this. And if we want to isolate the bit that is the loop addition, it's this bit here in the little blue box. And once again, I built it as basically a standalone circuit on strip board, and the strip board layout looks like this. So again, if you don't want the VCA part of this, but you'd like to have a nice looping AR envelope, then just build this and it works. So yeah, great. So what I did, I joined the two together and ended up with a VCA module with its own dedicated AR envelope. All these diagrams I've just shown you will be in my Dropbox folder, and again a link for that will be down below. Okay, that's the circuits, that's the board layouts, a little bit of kind of background as to where I borrowed them from. How does it work? Well, we'll go up to the synth, we'll have a look at the controls and the layout, and then we'll put some signals through it and you can hear what it does. This is the VCA module. The top controls is the envelope section. So you've got the attack control and release. You've then there's a CV in there. That's actually the CV trigger for the envelope, which is indicated on this little diode here. And then there's the loop function switch for the looping envelope. Underneath is the VCA section. So what it says here, CV level, on this green control here, that's actually the output from the internal output from the envelope passes through this level control to the CV control on the VCA, and then your audio signal being processed goes into the in socket, and then the process signal comes from the out socket. So that's the basic controls. Okay, we'll have a look at the patch I've got set up, and then we'll come back and listen to some of the sounds we can generate. I'll talk you through the patch that I've got set up for this demonstration. So we'll start with my multiple clock here. So I've got one output coming out of the clock and going into the input on my octavator. Now what this does, it actually uses the binary counter on the octavator. It's feeding it the equivalent of an LFO signal, which causes it to generate a repeating sequence. So I can use that repeating sequence of voltages to go into the CV input on my dual VCO, voltage control oscillator, and then I've actually got both oscillators switched in, and the output from the VCO is going into the input on the VCA module that we're looking at here. So that's that lead there. So that just basically provides me with a repeating sequence that we can then modify with the VCA module. To trigger the VCA, I have this long lead here coming out of a second output on the clock module and going into the external CV trigger for the VCA's envelope. And what I can do with this at the moment, with the switch here in the up position, it's synced to the clock signal that's driving the sequence. I can actually both turn it off and turn it onto an independent clock signal, but more of that later when we start playing around with some of the sounds we can get out of the VCA. So that gives me a CV trigger for the envelope section of the VCA, and then in order to hear what's going on coming out of the output from the VCA, we're just simply going into a mixer module, which is then connected to the audio mixing desk that's recording the audio for this video. So not a super complicated patch. It's just basically a VCO sequence that we are then manipulating with a VCA. Let's go and see what happens. Okay, so that's the patch. It's a relatively simple patch. So what I'm going to do now, I'm going to start the clock module, and then we can hear what output we've got. Loop function is switched off. So here we go. So we've got a fairly low attack, fairly low minimum attack, minimum release. You can kind of so you can hear what the CV level function does. It so it almost turns off the VCA. One thing I'm turning it down a bit. I'll say this, but one thing I did notice is that there's a very faint bleed through on the VCA. Now I might not have closely matched some of the components, but it's hardly noticeable really. So, but now it's well, It's another one of my quirky features in my quirky modules, but there you go. Let's bring the CV level back up. So you got a nice sharp. It's a little sharper than some of my Vactrol VCAs, which tend to kind of not be quite so punchy, and it's certainly nowhere near as noisy as the JFET VCAs that I've built earlier either. So it's different again. I'm kind of growing to like it. So if we turn the attack up, turn the release up. So if you remember from when we were looking at the actual patch itself, the CV trigger for the envelope is actually synced with the trigger for the activator, so generating the sequence, so that's kind of, they are triggering together. So what I'm going to do now, I'm going to turn the trigger for the envelope off, but it'll still be triggering the synced clock will still be triggering the activator, so we'll still get the sequence, but you won't be getting a signal through this cable. So essentially it turns off the VCA. Like I say, if you've got a really quiet environment, you might hear a tiny amount of bleed through. Let's hit the loop function. Let's turn. Another good reason to have the CV level control is that there isn't a close match between some of the external CV levels coming in and the internal loop level. So I can actually turn the CV level up on the loop so we can actually hear it. The other thing you notice as well, I've not linked the loop CV to the LED, so the LED is not working now. But we can still control the effect with the attack. There's no synchronization at all with the actual sequence now that's coming out of the activator. So you're starting to get some nice weirdo type effects. Now, because of the way I've wired it up, I can have both the external trigger and the loop function running at the same time. Because I've just used a simple, single pole, single throw type arrangement on the switch. It's actually a single pole double throw switch, so what I could have done is put the loop on one side of the switch and the external CV on the other side of the switch and have one or the other. But if I switch that clock back into sync again, I could have them both running at the same time. Now, I was worried this might get a little bit dodgy without some balancing on it, but so far, no magic smoke or anything. So, yeah. If you're worried, use the single pole double throw switch and have one or the other. If, like me, it's like, well, hey, let's see what happens, then, hey, let's see what happens. that's it with the synced clock. What I can do is use a completely independent clock now and have the loop and a clock independent of the sequencer clock. I'm twiddling the clock speed now on the independent clock. Back to synced, and it's so all sorts of weird and wonderful rhythmic kind of effects, but yeah, I think you kind of get the idea. Yeah, I'm going to have a lot of fun playing with this VCA with dedicated looping attack release envelope. And if you want to have loads of fun, I've shown you the circuit diagrams, I've given you the links as to where all the designs have come from, and go and do follow those and find out how things actually work in theory, and I've shown you how they work in practice. You've got the circuits, you've got the strip board layouts, so yeah, go on, have a go, build your own.